actually we use it. Yeah, I'll show you a trick.
Okay. Okay. Okay.
But
So,
if you use a calculator, what do you get?
uh, 64.
Gives you 64. I'll just put it here for you. Yeah.
Oh, okay.
All right. Great. So here's that's through the calculator. But how do you do this without a calculator? Okay. You can do this as the square root. I'll just put 2 there nonetheless, right? 16, we know 16 is a square number. So that's going to be 4 squared, right? Raised to 3. Now we will do one of the things we know about exponents. This will be equal to, I'll just remove the 2 and square root. This will be equal to 4 raised to 2 times 3, right? Then I'm going to switch them over. 4 raised to 3 times 2, right? And now I'm going to rewrite that as 4 cubed squared. So this gives me 4 cubed. And there it's going to be easier to do 4 cubed rather than 16 cubed, right? Okay, so this is going to become 64. This is going to be 4 times 4 times 4. 16 times 4 is 64. All right, so that's okay. I'll give you a similar one right now for practice by doing this, okay?
Okay.
All right, I'm gonna let me think. Okay, what is going to be 27 raised to 4 thirds?
4 thirds. So it's thicker one. 27 4 3.
Mm-hmm. And then the next one is 27 raised to 3 fourths. Okay. Okay.
27 4 3. Oh wait, no wait, huh?
Okay, just so we know, just so we're clear, this one's already simply not I'm gonna consider that correct, but you need to find this before finalizing, right? But aside from that, that should be okay. How about this next one?
Okay.
Oh, actually, no, this is incorrect. No, I just looked at it more carefully.
Yeah, it was just like, wait a second. I think I did something wrong. Don't mind me.
There we go. Yes. No problem, no problem. Okay, so this is the first one is not quite done yet. Okay. This second one is already done, more or less.
Okay. Because 27 is 3 times 3 times 3.
Correct.
That's good. And so then it's like 3 times 4.
Mm-hmm. Correct.
And then you kind of swap them
Mm-hmm.
with 3 4 3
Mm-hmm.
3.
Right.
These two cancel out.
Right. Exactly.
3 times, so 27 times 3.
I would think of it as 9 times 9.
Okay. 9 times 9, 81.
Yeah. Right? Because 3 squared, 3 squared.
Yeah.
Okay, great. So that's with numbers. This time around, I'm going to numbers are done. Okay, let's put some letters into the thing. Okay. All right. So let's do. I'm gonna do this now.
Okay.
Okay, 125 x cubed raised to, let's make it easy first, raised to 1/3.
Okay. So this would be 3,
Mm-hmm.
1, 2, 5,
Mm-hmm.
x 3.
Correct.
Now can I do 125, 3?
Yes. But what's 125 in terms of a cube of a number?
5.
Yep. Okay, 5.
Definitely. 5 times 5.
Mm-hmm.
25 times 5
Mm-hmm.
is 125. Okay, so it's 5.
It is 5. Great. Continue.
And then the 3's cancel each other out.
Uh-huh.
The cubes.
Uh-huh.
So there would be 5x.
Correct. Okay. All right. Next one, I'll make it a bit tougher.
Okay.
It is negative 8 x 6 y 9 raised to 1/3 again.
1/3?
Yep.
Okay. 1/3 minus 8x6. Wait, hold on.
There we go. Good, great. So y raised to
9.
9. Okay, good.
So 2 times 2 is 4 times 2 is 8.
Mm-hmm.
But it would be negative 2 because of the thingy.
Exactly.
So, yeah.
Uh-huh.
And then I mean, 6 divided by 3 because they can't really cancel out, but they all minus, not minus, but like.
Uh-huh. That's right. Okay, you divide, right. So,
Divide.
mm-hmm.
And then 9 divided by 3 is 3.
Okay, great.
Yay!
Okay. All right, so this now right. Now we'll do the reverse. We're gonna write um roots or surds. We're gonna write it as rational exponents. Okay, so I'm gonna say that first one is, what is the um y squared 3 cube root of y squared. This one should be easy.
Okay, that's a y.
Mm-hmm. That's a y. Yeah.
So we're turning it into a fraction exponent, yeah? Oh.
I think I was that. I think that was me. Hold on. There.
I was just like, huh? Where'd you go?
I accidentally. I usually do. I've been doing this for the past few days. I've been accidentally hitting the clear frame function here, so it clears everything when I press that. Anyway, there.
Oh no. Okay. So it would be y 2/3, yeah? Because like this is the
Yep, and
let's call it like
the numerator, right?
denominator.
Okay,
Numerator,
that's right. This is
denominator.
correct. Okay, so this one pretty straightforward. How about this one? A the 6.
A4, A4,
Yeah, that's a 4.
A4, 6. And I can simplify, yeah?
That's right.
Okay, so then A2, 3.
Correct. Okay. I'm gonna do one more. What is okay? Let's make it a bit more difficult. what is 81? I'm gonna say 81 x 4 eighth root of that. 81x to the 4. I'll give you a clue. You've done this before. 81 is equal to 3 raised to 4. That's your clue. Okay?
Okay. It's 3 raised to 4.
Mm-hmm.
Well, okay, I'm like blanking out for a second.
All right.
It would be 3x. Oh, wait, no. Okay. Then.
Mm-hmm.
So it creates 1/2. I'm just like, wait, hold on. How do I write it? I'm like, wait.
Okay.
No, 4 next to 81.
No, actually, this is correct. This is correct. Yeah. However, I would. Yep. I would put brackets here. Okay. Because
Okay.
3. I'm gonna just do it. Explain this real quick. 3x squared means 3 times x, right? However, 3x with a bracket squared like that means 3x times 3x.
Times 3x.
Okay, so
Okay.
so you need to write the bracket every time. All right, let's continue. And then last one. Okay, can you rewrite this? Rewrite as a root or a surd.
As third. Oh,
Mm-hmm.
it's this one.
Yep,
X.
done, done, and done. Yep, correct. All right,
Oh,
it's not it's not that
the 2
difficult.
is like automatically there already when it's like.
Yeah, that's right. It's automatically there, so you
The
don't
2
have
is
to write
already
2.
automatically there. Just like that.
Mm-hmm. Mm-hmm. Only for
Okay.
2, yeah? All right, since that's
Yeah.
done, let's now combine everything. Exponents, the loss of exponents, and the loss of roots. Yeah. So, how do we combine this? Let's start with numbers. What is 8 raised to 1/3 times 8 raised to 6?
Okay, so A is raised to 6. I'm gonna do that later. But the 38 times 8, 6.
Okay, I'm gonna stop you right there. That's a possible answer. So this is okay. However, you can also
Oh,
do,
really? Oh.
yeah, that's correct, but it's not a neat looking answer, right? It looks a bit weird.
Yeah.
What you could do here is you're gonna do the loss of exponents. 1/3 times 6. Sorry, plus 6, plus 6, right? So you're gonna be left with,
Yes.
that's gonna be 19/3. So 18 raised to
1/3.
19 over 3.
Mm-hmm.
Which, if you simplify back into into a root, it's gonna be the cube root of 8 raised to 19, which looks a lot neater. Even though it looks a lot more difficult to solve, it does look neater, right?
Yeah.
Okay, so this is one thing you can do. You can always add these numbers up just like normal exponents.
Okay.
All right, so how about this? Let's another one. I'm gonna say 4. No, I'm not gonna say 4. I'm gonna say 3 raised to 2/3 times 3 raised to 4/3.
So then this 3,
Mm-hmm.
2, 3 plus 4, 3
Uh-huh.
equals 6, 3,
Uh-huh.
which makes 2,
Uh-huh.
which means 3, 2.
Uh-huh. Then simplify.
Okay. 9.
All right, done. Great.
Yay!
Okay. Uh, hmm. Let's do one more and then let's go to division. Okay, let me think. Okay,
Oh gosh.
this is 2x 3/5 times, okay, I'll use a dot this time, times 4x 7/5.
Mm-hmm.
You know what? I'll make it a bit easier. I'll remove the 4 for now.
Okay.
Yeah.
So it would just be 2x
Mm-hmm.
3/5
Mm-hmm.
plus 7/5, which makes 10/5,
Mm-hmm.
making 2.
Mm-hmm. Great.
And it's only applied to the x, yeah?
Yep, it only applies on x.
Okay, so it should just be 2x2 or 2x.
All right, correct. Oops, I had the eraser on.
That's
Correct.
oh,
All right. So, okay, multiplication done. Let's do some division.
okay.
Okay. Okay. Next time I'm gonna say what is x raised to 3/5 divided by x raised to 2/5. 2/5. Again, so apply the rules and then simplify.
Minus the 3 minus the 2
Mm-hmm.
minus 2, 5,
Mm-hmm.
1, 5.
All right.
So and this one would just be gone, right?
Not base something like that. Yeah, that would disappear somehow. So what's the final answer now?
So it would be x 5, yeah, because of the exponent thing.
Aha, that's correct.
X.
Nope, you almost got it. Just this was enough.
Oh, really?
Yeah. I'll show you why. Yeah. So this is right. So this means you get x to 1/5. X raised to 1/5, and by definition, that's already the fifth root of x.
Mm-hmm.
Okay. So this 1/5, yeah, this disappears. Everything disappears. You're left with only x.
Oh.
Okay.
Oh.
All right.
Wait, is it because it turns into a 0, which means x equals 1?
Something like that. I think I better show you. Better show you like this. So what's gonna happen here is if I'm gonna rewrite it properly, 3/5 here, that's gonna become times x raised to negative 2/5, right? That's why it becomes 1/5.
Oh.
So this turns into that. Okay. And then once we get this,
Okay.
it's exactly that.
Okay.
All
Okay.
right.
Okay.
Okay. Okay, let's do another one then. Let me get a number. What is b raised to 3 sevenths divided by b raised to 7 over 9? Yeah, I'm a bit evil in this case. Actually, no, I'm gonna change that 9. I'm gonna change that. That's too hard. I'm gonna say 7 thirds. There. Yeah, we can do the hard one later.
Okay. Okay. This. I don't think I can really. I want to do the
Okay.
simplification.
Now, okay, I'll stop you right there. Okay. Remember, you don't go straight into finding these roots. It's actually gonna be harder to do it like that. Okay. You go into changing the exponent here. You change this to a negative exponent. So basically, you need the multiplication bit. Okay. So something times something, and then you do the trick with the exponents. So the last thing you would always want to do is actually convert into the root. So don't do the roots until you're at the very end.
Okay. So I want to turn that negative.
Yeah, so you want me to show this for you before we continue? I'll give you another one later. I'll just show this to you first, alright? So this is gonna be b raised to 3 over 7, right? Times b raised to negative 7 thirds. Okay, and now that's gonna turn into b raised to 3 over 7 minus 7 thirds, right? Now, 7 thirds. So now we're gonna get the equivalent fraction there. It's gonna become 3 times 3 is 9, minus 7 times 7 is 49, all over 7 times 3, 21, right? 49 minus, yeah, 9. So this is gonna give us b raised to negative 40 over 21. And there, we cannot simplify that further. That's when we turn it into the surd. That becomes the 21st root. The 21st root of b raised to 40. Okay? Alright. So either one of these would be correct. Okay? Alright. Okay, I'll give you another one now. I'll just do it here. I'm gonna say x raised to 2 fifths divided by x raised to 5 halves.
Then you do what you did.
Yes?
B 2/5
Mm-hmm.
times. Oh, no, that's Hold on. X.
Oh, okay.
X negative 5 2. And then
Sorry, Arya.
simplifies.
Mm-hmm. Okay. Arya has joined us on the stream.
Oh, hello.
Okay, so far, okay, this is correct so far. Mm-hmm. Correct.
And then you do the X 1. Yeah.
Okay, correct. And just do the last bit and you're done. You can keep it as the rational exponent form. You don't have to turn into the surd.
Okay. 21, 10.
All right, so that's correct.
That's
Okay. So division's done. Um, okay, let's do the next bit. Let me see now. Okay, let's do something like let's do this. I'm gonna say hmm. Okay, let's do 32 a raised to 10 b raised to 20 raised to 3/5. Let's simplify this. Oh, hold on. I'm gonna add something. A negative sign. I'll add a negative sign
oh, okay. Right.
there.
So it's okay. Oh gosh. So we want everything to be like that.
Uh-huh.
Okay.
Okay, go ahead. If you get stuck, I'll help you. Once you get stuck.
Okay.
All right. So while you're there, hold on. Arya, can you see it now?
Has it not been showing?
Yeah. Apparently, it's been showing my face the whole time.
Oh. Go back to the slides.
Yeah. I'll go back. I'll recap the other slides later when we're done.
Okay.
Okay. Correct.
So,
Yes.
35,
Uh-huh.
and I can simplify those other ones. I'm gonna do that right now.
Yeah. Just go ahead. Simplify that.
Okay. So that would be 6
Uh-huh.
be 12.
Correct.
Mm-hmm.
Mm, you're almost
And then
done.
like simplify.
Yes. You have to.
Simplify the 32, yeah?
Mm-hmm.
Okay. Wait, that's a really big. 5, 30, 2, 3.
Uh-huh.
No, no. A 6, B
Okay.
12.
Then one
Can I
over.
simplify 32 more?
Yeah, you can actually. Okay, I'll stop you right there because I want to show you the shortcut. So this is the correct step. Yeah. I'm just gonna. Okay, what I'll do now is basically I'm gonna show you the two steps. I'll continue this for now. Yeah. So you said that that's equal to that, and I'm just gonna write the a raised to 6, b raised to 12 here. Then this becomes 32 is the fifth root of 2 raised to 5. Is it cubed, right?
Uh,
So
yeah.
so this we can apply the shortcut now since we are familiar what happens. That 5 and that 5 cancel out,
Yep.
right? So you're left with 2
Yes.
cubed,
And then it's 2, 3,
a6 and
2
b12. So that's finally
which
gonna give
is
you
8.
8 a6 b12, right? So this is the way that we did
Yeah.
earlier. Now here's a shortcut. Here's another shortcut. Okay, I'm gonna write 32 straight away as 2 raised to 5. So the
Huh?
short, so that's gonna be 2 raised to 5 raised to 3/5. Okay, so if we I'm gonna rewrite it here as the whole fraction. So that's gonna turn into 1 over 32 is 2 raised to 5 raised to 3/5
Mm-hmm.
times a raised to 6 b raised to 12, right? Okay, so what's gonna happen? That 5 here and this 5 here cancel out. So you're left with 2 cubed.
Mm-hmm.
Okay. All right. So we're left with 2 cubed, a6, b12. And then we get the exact same answer,
Yep.
right? So both techniques are right and they're equally valid. So it's up to you which one you want to use when you're solving. Okay. All right. I personally prefer the other one, the second version. This one.
Bit quicker, right?
It's a bit quicker. Yes, I prefer that. Okay. All right. Let's do another one similar to this, and then we move on. We move on again. I gotta think of
Okay.
numbers. Hold on. Okay. I'm just gonna say 1,000. Uh, this should make it easier because that's 1,000, right? X
Yeah.
raised to 6, y raised to 9, z raised to 12. Um, 4/3 raised to 4/3.
Okay. Great times.
Mm-hmm.
1,000, 30. I'm gonna try it your way.
Right.
Or let's do everything else. 24, 3,
Okay.
y, 36. Yeah,
Mm-hmm.
that works. Z, 48, 3.
Uh-huh. Okay.
Wait, that's
Okay. You made a small
supposed to be
mistake,
4.
but yeah, you spotted it. Great.
Yeah, I'm just like, look through it, I'm just like, wait a second.
Mm-hmm.
So then, this would equal 10 threes,
Mm-hmm.
and the 4 3,
Mm-hmm.
these two cancel out.
Great. Okay. Then you start you do the divisions for x, y, and z as well.
Yeah. So 10, 4. I don't want to write all those zeros.
Mm-hmm. It's fine.
Um,
Keep it like 10 to the 4. It's fine.
24 divided by 3 is 7.
Uh-huh.
36 divided by 3 is 12.
Uh-huh.
And z divided by, no, 48 divided by 3 is 16.
Correct.
Yay!
Great. You're getting the hang of it. Good. I will show you another shortcut. Okay.
Shortcut.
Yeah, another shortcut here. Okay. I'm gonna go straight,
Mm-hmm.
and you see this 4/3 as I'm
Yes.
gonna write that 1,000 like 10 cube already. Right. I'm gonna start
Okay.
there first. X6,
Mm-hmm.
Y9, Z12. Right. And
Yeah.
that's 4/3.
Mm-hmm.
Now, that you notice that all of these exponents have a factor of 3. So I can just put that 3 and cancel all of those 3's with the 3's here. So this is left with
Yeah.
1.
Oh.
This is left with 2. This is left with 3. And this is left with 4. Right?
Mm-hmm.
So I'm going to
And
put the
then,
4 in now. So 10 to the 4, x to the 8,
oh,
y to the 12, and z to the 16.
oh, that, I like that.
Yeah, you can do this technique once, of course, once you're familiar with working with everything, yeah. So
Yeah,
this
yeah,
will
yeah.
only work. Actually, this will work no matter what the numbers. So what do I mean by that? So for
Oh.
example, what if I had 1000 x6 y9, but instead of z to the 12, I have z to the 11, right?
Mhm.
It's still gonna work equally well, but what will happen? This is gonna become 10 cubed, x6, y9, z11 raised to 4 thirds, right? So this 3 kind
Uh-huh.
this 1/3 kind of cancels, kind of goes into everything, right? So that turns to 1,
Mhm.
that turns to 2, that turns to 3, but this cannot be divided by 3, so we just put 11 over 3.
Oh, okay. That.
And then we put the 4 in. So
Okay.
that's going to be 10 to the 4, y8, at, yeah, y8, x, sorry, x8, y raised to 12, and finally that becomes z of 44 over 3. Okay?
Mhm.
All right.
Yeah.
Okay. Okay, let me see. We can do
Uh,
one more, and this time I'm
I'm
gonna.
just try that
Okay,
method.
the last one, and this is like you're gonna simplify. I'm gonna ask you to simplify a division. What is the
Mhm.
square root? What is the fourth root of 3 divided by the fifth root of 6?
So fancy.
Mm-hmm.
The 4. Okay.
The last one,
Oh.
and then I think you have to go after this, right? So yeah.
Mhm. So wait, should I turn it into like the fraction form or no?
Yes. Yes.
Okay. So 6 is 1/5 and
Mm-hmm.
3 is 1/4.
Right.
Gonna rewrite that. And then we do the thing where we make the 1/5 negative, yeah?
Mm-hmm.
I don't know what I'm supposed to do with the bigger number, so we're just gonna.
Okay. Hold on. I think I'll change a number. I'll change this to 9.
Okay.
And that way we can work with it. Yeah, because if it's 6, we're stuck there. So we'll just change that
Mhm.
9 for you there. Yeah, and then
Okay.
change that to a 9. Because this time, if it's a 9, you can do something with the 9,
So would
right?
it just? Mhm. Would it be 3?
Yes.
Okay.
3.
And then 5 minus 4
Uh-huh.
divided by 20. Yeah. Is that
No,
it?
not quite. Not quite. It's not minus 4.
Okay. Minus 4.
No, it's not quite because remember that 9 is equal to 3 squared, right?
3 squared, yeah.
So this
Oh!
becomes what?
So then it would. So this 2. So,
Mm-hmm. There
8.
we go. There we go.
8!
Yes.
Yeah! Okay, um, so then this. And then this would
Over.
still be 20, yeah?
That's still 20.
Okay. I thought I just got the 20 part wrong.
All right.
And
Okay,
then
so
it would
that's it.
be. Yep. The minus 3. 20. Blah, 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 blah.
Done. Good.
Yay!
All right. So if you want to turn that last bit, I'm just gonna say this now. Okay. You can also say that as write that down as the 20th root of 1 over the 20th root of 3 cubed.
Mm-hmm.
Okay. All right. So of course you
Okay.
can simplify the 3 cubed later on, but for now I guess we can end here. All right.
Alright.
All right. So I'll see you again next week. So again, if you have
Mhm.
anything, oh, next week you let me know what's gonna happen. Yeah.
Yeah, my mom will probably send you something or
All right. Okay.
about it.
All right. So have a
Okay.
good day. Enjoy
Bye.
whatever you're doing
You.
afterwards. Bye bye now.
All right. Have a good day.
You too. Okay, so that's it. I made so many errors in this stream today. I don't know why. I had the student. I had Ariana's audio off, but before that, I wasn't showing the board. So what I'll do is I'm gonna do a quick recap of everything we have here. So let's start from slide one. Okay. Ariana's topic was about rational exponents. So whenever rational exponents means, okay, whenever we say the word rational in math, this means fraction. Why? Because rational comes from the word ratio. It's not rational like they make sense, but it's rational like they form a ratio. So, ratio, and we know that ratios can be written in the form a over b. That's why we call them rational numbers. And in this case, we're doing rational exponents. So this is the exponent right here. Okay. Now, the recap we did earlier was the law of exponents. So, of course, the definition of the exponent, a raised to n, is given here. You're multiplying a by itself n times, that's a raised to n. Okay? If you're multiplying a raised to n by a raised to m, you add the exponents. We're not going to go through how, maybe in a different video. Okay? But here, a raised to n divided by a raised to m, you're going to subtract the exponents. If you have a number that's already an exponent or in an exponent form, and then you raise that to another exponent, it's the same as saying that. Now, what I didn't write earlier is this is also equal to a raised to m times n. Why? Because you can swap the order of the multiplication. In other words, it's commutative, right? And therefore, that should also be the same as saying a raised to m raised to n. That's going to be useful with the solutions we had earlier. Okay, and two more. A raised to 0 is 1, and a raised to negative n is equal to 1 over a raised to n. Okay. Uh, okay. So for rational exponents, so they all follow the same rules, and there's a new definition. 1 a raised to 1 over n is equal to the nth root of a. So here are the examples we did. So we started off with numbers. What is 9 raised to 1 half? That's just the square root of 9, and therefore we get 3. Okay. Now, if you have, in this case, this is going to be equal to the 16 cubed, then you take the square root. This happens because this is equal to 16 cubed times 1 half, right? 3 times 1 half, and you can rewrite that as 16 uh, cube raised to 1 half. So that's how we got that. Okay. Now, if you put that in the calculator, you get 64 right away. But you can actually work this by hand if you know that 16 is 4 squared. Why? Because once you write it like this, again, you can swap the exponents around, and therefore you got that. So square root of 4 cubed squared. Since the square root of a square number is the number itself, that's what we get here. And then, of course, we simplify 4 cubed. 4 times 4 times 4 is 64. Okay, the third thing we were doing, okay, so this one is correct because this cannot be further simplified. This is already too big, or rather too complicated to just simplify. So that's already it. If you want to, you can expand 27 cubed, but that's a big number, so we'll leave it as this. Okay. However, on this other one, okay, the trick here is again the same thing. You write 27 as 4 cubed, and then the cubed is multiplied by this 4. Then you swap them over. 3 raised to 4 times cube times 3. This 3 and the cube root cancel out. And 3 raised to 4 is 3 times 3 times 3 times 3. Or 9 times 9, which is 81. Okay. And the rest of these follow basically You just do it like that. And if you can simplify, just simplify. Here's the example here. A raised to 4, you take the sixth root. It's the same as saying a raised to 4 over 6. And you can simplify the numbers into 2/3. So you can actually, I'll just write this as well. This is also equal to the cube root of a squared. Cube root of a squared. Okay. If you have numbers like this, make sure if you're multiplying numbers like these, make sure that if once you get some sort of exponent in common with them, in this case 4, because of this, right? Make sure that the 4, once you factor out, or once you remove this 4, you put that in brackets. Okay. So 4 over 8, this is the 4. The 8 becomes a denominator here. 4 over 8, this becomes that, becomes the square root of 3x. Okay. This, we've done it first with numbers. What if you're multiplying two numbers with exponential or rational exponents? The idea is still the same. You're going to add these when you're multiplying. So that becomes 1/3 plus 6. And simplifying, that turns to that. Okay. Same thing here. You're going to multiply these two. You're going to multiply these two. You're going to add them here. So that becomes uh, yeah, it becomes 9 in this case. Why? Because 2/3 plus 4/3 is 6/3, which cancels to 2. So that's 3 squared, which is 9. Okay, so here we have 2x raised to 3/5 times x raised to 7/5. Again, the 2 here, you can think of this as 2 times, then we will regroup x raised to 3/5 times x raised to 7/5. So that's why that kind of looks like that. And then 3/5 plus 7/5 gives you 10 over 5, which is 2. So we're finally left with 2x squared. Okay. And the rest of this will follow, I think. Yeah, we'll end it here. Okay. So, here. I think before we end, I want to go through this problem. So this one, again, I think everything was in proper order now. But basically here, you write your 1000 as 10, 10 cubed. That's 10 cubed. So 10 cubed times 4/3 gives you 10 raised to 4. Okay. Now a shortcut is you can just put this into each exponent individually and do the divisions. You don't have, in fact, it's easier to do division first than the multiplication first. Because in this case, you're going to have to, here, Ariana did the multiplication first. For me, I find doing the division first easier because it's going to give you smaller numbers. Smaller numbers are way easier to work with by hand. Okay. All right, so we'll end the stream here. Hopefully that was helpful. So with that, I'll bid you all good night, good morning again, or wherever you are in the world. Good night, good morning, good evening, good afternoon. And until next time,